Hey, what's going on, guys? Xiangqi here. Just to give you an idea of what I've already done with the Stockfish's source code, you just read the title of this video one more time and then have a look at the source code. But beware though, if you're a professional C++ developer, you're probably better not doing that because your kind of feelings might get offended, and I'm not really intending that. Okay, I'm just kidding, guys. So the last video we ended up with mode generation, so you probably remember that I have replaced the Stockfish's mode generation with my own with two routines. So all the code that belongs to original Stockfish's mode generator is no longer working. It's no longer working. But I didn't yet get rid of this because of the compilers, so it still lives there. So I'm gonna clean it up one day. But here are two essential functions actually generating all the pseudo-legal moves for all the pseudo-legal moves to traverse the tree, basically. And now I've added a new template that calls pseudo-legal move, pseudo-legal. So it generates this pseudo-legal moves. So original Stockfish was the original Stockfish's do move function that is available here. It's no longer available because of butchering Stockfish and burning bridges, as the video title says, basically. So it was relying. The only thing left from original Stockfish is actually this commentary makes move and saves all the. This is the move is assumed to be legal. Pseudo-legal moves are to be filtered before. So I just get rid of this, and this is assumed to be pseudo-legal like this. So now this is correct. Okay, so I didn't yet implement this. I'm still gonna be doing that, as well as the take back. Really lots of work. But anyway, what I did so far. So if within the previous video we were just printing the generated moves on the fly, just printing them to console. Now I've already implemented encoded and decoded moves as it was done in Stockfish, but the layout of move encoding layout of the move is now completely different. So here is the routine to encode the moves. So I'm not only encoding source and target square, but also source piece and target piece. Target piece that's needed for the current particular architecture that I'm using from my JavaScript Chinese chess engine Wukong. So just to give you an idea, so here is the map for move encoding. So I'm using the first 8 bits to save the source square, then 8 bits to save the target square, and 4 bits for source piece, 4 bits for target piece, and the only bit for a capture flag. That's the only thing that is a bit similar to how it was in Stockfish before. And the routines to actually encode move and to extract the source square, source piece, target piece, and the capture flag back from the move, which is gonna be done within this do move and undo move functions of the position class, the core methods of the position class. Okay, so also I've also altered the UCI move. Let me just quickly check that. So at the moment I'm just using this lookup array that I've been using within the mode generator. Just grab that from there, cut from there, paste here. So just easier to use it straight ahead, just as a lookup without being bothered by constructing this by hand. This sort of a strength. So now we already have moves being encoded as integers. They are not getting scored yet. They will be getting scored, and that's another way. And that's another reason why I call this video butchering Stockfish and burning bridges. So I'll just tell you about this a little bit later. So anyway, now we do actually use this get. So we're just extracting the source square and target square from the move and converting this to string and output into as this move. Then it gets printed. So let me just run this. So it has been running before. Here are a couple of warnings because my do move function is just an empty one. That's the reason for the warnings. Just doesn't yet contain any code literally. So see, like just an empty one. That's the reason for this unused variables. But yeah, and here, so I'm just bringing the board to console. This is how the Chinese chessboard looks like. So this white to move down below, so like in the international Western chess. And here I have the root moves being generated for this current given position. And again, like these moves are already being encoded as the integers, and the move list has been populated with this sort of a moves. So from now on, I'm populating the move list right over in here, then return the move list. Then every time I try to push the move to the move list, I also do update the pointer to the move list, and eventually I return the pointer from generate moves, and then I return the pointer back to the routine that actually starts generating the moves. So the way how the moves are generated is one of not many things that still remains the same from the original Stockfish. So just let me quickly demonstrate you that. So position, no, movegen.h, I need the file movegen.h. So this is it. The move list structure is a wraparound generate. So it allows to use a fancy way of looping of all of the moves, which is a bit new to me, but as far as I did manage to master it, well, master probably not the most appropriate word, but anyway, I managed to make use of it, let's say. Yeah, so another thing I've did, so I've disabled the original perf. No, I didn't yet disable it, it's still there, but I've created a new perf function that is globally visible across different files. So I'm still a bit new to this namespace stuff in C++, but anyway, now at Verolist I can call the function from a different file in my main CPP, which for me personally is already a matter of big joy, to be honest, because when I just started with this project, it was completely unclear how the heck one would be calling the function from other files. So I wasn't really clear about this namespaces and how the things are done. Okay, guys, so now what happens actually? So you see, like I've butchered lots of things that were originally in Stockfish. So I allowed just I don't even initialize the position, because that's the matter of initializing the hash keys and related stuff. So at the moment I don't have that. I will be adding that later on, obviously. I've also disabled threads, so now I can actually disable threads as well, because I've altered the position set fen to not rely on the current thread, and not using the Boolean value of isChess 960, which was in the original Stockfish, because it's not going to be playing that variant. Okay, so yeah, I'm just wondering, this still should compile and run. Okay, so okay, now another thing. So I've disabled threads because the way, yeah, hopefully works. So yeah, now completely butchered things. Okay, cool. So yeah, now I can actually work with the position, with the only position, because before we had kind of position related to thread, and that was a bit of a pain to debug for me personally without that clear understanding of threads, especially how they work in C++, all this low-level stuff. I have a bit of experience with threads in Python, but in C++ it's a little bit of a pain to deal with. Okay, but now I can actually comfortably debug all this stuff, and I don't even need the UCI loop anymore in order to like print position and things like that, because without the threads you can just customly create a new position object instance and do all the stuff I actually want. So no longer to do this via the UCI interface like I've been doing before in the previous videos. So the next step, so this is it actually, and now kind of like a logical question arising, like what actually left from Stockfish, and what would eventually be left from Stockfish. It's really hard to say, because literally the only thing I need from Stockfish is the position class interface and the search function and the UCI protocol communication. That's it. So that's literally it. That's literally what all I need from Stockfish. I don't need anything else. because I really want this powerful search. And again, like regarding another things like, I don't know, like say threads. Well, at the very least, what I can say that the current the matter of having this position object already allows to use those threads one day, if I would leave, if I would be alive then and smart enough for that, or probably someone would join the project and alter this. I don't know, just hard to say really. But at very least, first I'll be able to make a working engine. Then I'll try to clean up all the unnecessary things, and then again, like nothing can stop from being inspired from the actual Stockfish's implementations of all the bells and whistles, so they can be added later on. But my approach is actually to divide and conquer things and make sure that I completely control the process of what am I doing. So yeah, that's kind of it. So threads are no longer on the cards, no longer used basically. And obviously, yeah, and one more little thing which also surprised me a little bit, because when I was disabling the threads, I realized that I finally realized the way how Stockfish initially scores the moves for the later move ordering purposes. So it has some sort of so-called root move structure. So we go to threads.h. I believe that's the place where it lives. Threads.h, and nope, not here. Okay, where are the root moves? Are they in search? Oh, sorry, yeah, obviously they are in search. So I'm no longer using this stuff, yeah, because I'm gonna be assigning the scores for in Stockfish. This is called value. I just want to see this move list. Move structure. So the move itself, encoded as integer, and the value for move ordering. So this value would be initialized in the move generator, as I did many times before. That's not the best ever kind of like not the best ever thing to consider, but actually that's something I do understand now. So probably, well, if I would be smart enough, one day probably I would be able to use this root move stuff, but at the moment it's a little bit of a rocket science to me, to be honest, guys. So just really don't want to involve something that I do not understand and something that I can't control. But meanwhile, I would be able to make use of the power of Stockfish search, because it's definitely much better compared to the search that I had in Ukon. So anyway, the engine would be stronger and faster. It won't be as strong as fast as Stockfish, and also bearing in mind the evaluation. So again, like definitely the evaluation would be written from scratch, and I would be reusing the evaluation from Raccoon initially, and then we'll see how it goes. NNUE is preferred way. One day when Fabian Fichter would implement that for Fairy Stockfish and kindly allows me to reuse his work. I don't know, so it's really hard to say. But at very least, guys, like what I can say from my side, that until this day, tinkering with the Stockfish's code wasn't really on the cards, wasn't really available for noobs like me, right? But from now on, you don't really have to be super world class C++ developer in order to understand what's going on within the code, and it's much easier now. It's way more straightforward now. So it's I really kind of butchered. I don't know. Maybe I don't know how many percent did I butcher. Have I butchered from the Stockfish already? It's hard to say. We'll see later on. Probably after cleanup. So I really want to get rid of all the files that I don't need. So let's say I don't need bitbase, bitboards, endgame. Evaluate would be I'll make my own. So this would leave. Material is not needed. Movepick, not sure. Pawns is not needed. And what else? Threads is not needed. Time manual transposition table probably would be involved. UCI option also. So yeah, so really want to get rid of all the unnecessary files that I'm not using really, but at the moment I can't do this because of tons of compilers. So, you know, like even removing some existing parts, even the buttering is actually the way to learn for me, because when you cut something from the engine, you actually start to realize how it was working. Maybe not in the most, maybe not in the greatest details, but still, at least, kind of like, yeah. So that, which means that with the current structure and with the position object being encapsulated into the class, it's always possible to restore things back. But if I would ever be doing that, I would be doing that my own way, and even if that way would correlate with the Stockfish's way, at very least I would be understanding what am I doing, because I don't really want to use some piece blindly use. I don't really want to blindly reusing some pieces of codes that I do not actually understand why they are needed or how exactly they work. So that's one of the most important things, one of the most important development principles, basically. Okay guys, so I think this is it, and again, like the next steps for me is to actually implement this do move and undo move and run a full perf test. I will also need the e-square attack function to be implemented, yeah, but yeah, that's just not really that important in the moment. Well, the function is absolutely essential, because otherwise it just won't be possible to make legal moves. But anyway, so I hope this is clear and makes sense, at least for those guys who has a similar approach to my own or a similar understanding. I'm not actually promoting the way I am, the way I code. And again, like as I've been mentioning many times before on the forums, etc., that I'm not doing this to offend somebody or just I'm doing this only because I can't go another way. This is the only applicable way for me. This is the only way how I can go, because if I was going like traditional way, like going to university, all this stuff, all this business bullshit, in that case, you know, like, yeah, I would never be ever where I am now. I would never be working as an expert on chess programming. I would never be making money on chess programming like I do now. So everything I do is possible thankfully to this sort of an approach I'm sharing with you guys. So again, like if any C++ developer was hurt during watching this video, I'm really sorry for this, guys. I really didn't mean that. So wish you all the best, and see you, hopefully to see you in the next video on perf testing of this current node generator I'm working on. So this is it from my side, guys. Thanks for watching. Until the next time, and take care.